Good evening to all. Myself A. Pravalika from the Department of ECE A section. Welcome to Signals and Systems. Today we are discussing about Fourier series. Four types of series: Fourier series, trigonometric Fourier series, exponential Fourier series, cosine series, Dirichlet conditions. What is Fourier series? The Fourier series is a mathematical method to represent a periodic function as an infinite sum of simple cosine and sine waves, each having a frequency that is an integer multiple of the function's fundamental frequency. This process decomposes complex periodic signals into their simpler constituent wave components, which is widely used in fields like engineering, physics, and signal processing to analyze and model wave patterns, vibrations, and alternating currents. Types of Fourier series: trigonometric Fourier series, exponential Fourier series, and cosine Fourier series. Trigonometric Fourier series. Definition of the trigonometric Fourier series. Presentation of trigonometric Fourier series. Example of Fourier series. Trigonometric Fourier series. The trigonometric Fourier series represents a periodic signal as an infinite sum of simple sine and cosine waves. The original signal is decomposed into its constituent frequency components, which are integer multiples of the fundamental frequency. The trigonometric Fourier series is defined as a method to represent periodic signals using sine and cosine functions derived from the exponential form. What is the trigonometric Fourier series? This is the wave function of the trigonometric Fourier series. Presentation of trigonometric Fourier series. The trigonometric Fourier series representation of a periodic signal x of t with fundamental period t is given by x of t equals to a naught plus summation k equals to 1 to infinity ak cos k omega naught t plus bk sin k omega naught t into omega naught t equals to 2 pi by t naught. The trigonometric Fourier series representation of a periodic signal x of t with fundamental period t is given by ak equals to 2 by t naught integral t naught x of t cos k omega t dt and bk equals to 2 by t naught integral t naught x of t sin k omega t dt. A naught is the DC component of the signal and is given by a naught equals to 1 by t naught integral t naught x of t dt. Example of trigonometric Fourier series. Trigonometric Fourier series explanation. Let us begin by considering a function f of t which is periodic of period t, that is f of t equals to f of t plus tau. As Fourier showed, if f of t satisfies a set of rather general conditions, it may be represented by the infinite series of sinusoids. F of t equals to a0 2 plus a1 cos omega t plus a1 cos omega naught t plus and so on, b1 sin omega naught t plus b1 sin omega naught t plus and so on, or more compactly. Fourier series example. Determine the Fourier series of the function f of x equals to 1 minus x square in the interval minus 1 to 1. This is the example for Fourier series. Exponential Fourier series. Definition of the exponential Fourier series. Representation Fourier series. Example of Fourier series. What is exponential Fourier series? The exponential Fourier series offers a compact and efficient representation of periodic signal using complex exponential instead of sines and cosines. The transformation simplifies mathematical analysis in the context of signal processing communications in systems engineering. The Fourier coefficients into a signal complex term, it becomes easier to manipulate, differentiate, integrate, and analyze signals in both time and frequency domain. This representation is essentially powerful in applications such as modulation, filtering, and spectral analysis, where working with exponential functions naturally with the behavior of linear time invariant system. Exponential Fourier series analysis. Representation of exponential series. The complex exponential Fourier series representation of a periodic signal x of t with fundamental period t0 is given by r of t plus t equals to r of t for all t. This is the equation of representation of exponential series. Example of exponential Fourier series. Here we consider the original signal to be a contains periodic continuous triangle wave and derive its Fourier series coefficients. The detailed steps are not shown below. We start with the function form of the original triangle wave. This is the example for the exponential Fourier series and the waveforms of the exponential Fourier series. Cosine Fourier series. What is the definition of cosine Fourier series and representation of a cosine Fourier series and the example of the cosine Fourier series? What is the cosine Fourier series? This section we are going to take a look at Fourier cosine series. We will start off much as we did in the previous section where we looked at Fourier sine series. Let's start by assuming that the function f of x we will be working with initially is an even function, that is f of minus x equals to f of x, and that we want to write a series representation for these functions in the terms of cosines which are also even. Note as well that we are assuming that the series will in fact converge to f of x at this point. In a later section, we will be looking into the convergence of these series in more details. Representation of Fourier series. Fourier sine and cosine series. F of minus x equals to minus f of x. F of minus x equals to f of x. Example of cosine Fourier series. Find the Fourier cosine series for f of x equals to x square on minus L less than or equal to x and less than or equal to L. This is the example for cosine Fourier series. Dirichlet's conditions. Dirichlet conditions. A periodic signal x of t has a Fourier series if it satisfies the following conditions. First one, x of t is absolutely integrable over any period, namely integral a to a plus t mod of x of t dt less than infinity. Second one, x of t has a finite number of maxima and minima over any period. X of t has only a finite number of discontinuous over any period. Thank you.